So we go to radian mode, and then look what I had us do. I said, let's go graph the following functions in radian mode, but look what I'm going to have us do, changing our windows. So do me a favor. We're going to go to the y equals screen. We're going to say we're graphing sine of x. And then in the window, I want us to change our window to this. Okay. So you guys, I want my x min to be negative 2 pi, not negative 10. So I'm going to go change my x min to negative 2 pi. I'm going to go change my x max to 2 pi. Does yours go to a decimal or do they leave it as 2 pi? Yeah. 2 times 3.14159 is going to get me that 6 point. My x scale, I'm going to make it pi over 4. My y min, I'm going to make it negative 4. And my y max, I'm going to make it 4. Again, I got those numbers from right here. Okay, so you guys, I said graph this function sine. Let's remind ourselves, what's the period of sine? Period of sine? 2 pi. So I said, let's go graph it. I want to graph what's on your calculator, but look at what I did, you guys. Here's 1 and negative 1. Don't forget, so before, like on your quiz, I was putting 1 and negative 1 all the way at the top and the bottom. So here's 1. So if I were you, bless you, Steph, I would go ahead and say, all right, sine goes as high as 1 and as low as negative 1. I like to kind of draw those in as my guidelines. I cannot go beyond those guidelines. I can't go higher than that, and I can't go lower than that. Where does sine start? Origin or at 1? Origin. So I'm going to go put a dot at the origin. And then you just said, what's the period of sine? You said it's 2 pi. So I'm going to go back to that origin spot at 2 pi. So at 2 pi, I'm going to have a 0. Do you agree? At negative 2 pi, I'll also have a 0? Okay. And then sine starts by going up first, right? So I got to go up to 1. I got to go back down. Then I got to get back here. So do you agree? At pi, I'm going to have another 0. And at negative pi, that's like my in-between, my midpoint. And then between these pinks and blues, I got to go up. So at pi over 2, I'm going to get to my highest point. I'm going to put that in black. And at 3 pi over 2, I'm going to get to my lowest point. And I'm going to continue that pattern. And I'm going to draw my beautiful curvy sine graph. Let's go see. We've known that. Now look what I'm having us do. Now I want us to graph negative sine. So we're kind of saying, oh, it just kind of flips it. What would you say the difference between blue, which was sine, and red, which is negative sine? What do we do first with red? You just go down. So what is negative sine, you guys? We just go down. So I still have my guidelines of up as high as 1 and down as low as negative 1. Sine still starts with the origin. So I'm going to say, all right, I still start at the origin. Is the period of negative sine still going to be 2 pi? Yeah. And instead of going up first, I'm going to go down first. So I know I'm going to go down, back to the 0, up. Oopsies. What did I do wrong? Yeah, I think that they help. I think that they help, especially with what we're going to do, Labeo, with, it's going to get more complicated. So I think having the guidelines will help. So you agree. If we have positive sine, cool. It starts with the origin. We go up. Negative sine, we go down. Okay. Here we go. Okay, now let's go to our graph here. I want you to follow along with me. Ready? I want you to go to that y equals screen. I want you to get rid of the negative sign, but I want you to keep the positive sign graph. And then as your y2, I want you to type in 3 sine of x. So look on my graph. I'm keeping sine, and then in y2, I've got 3 times sine, because I want you to see those graphs. Yep, we still have a period of 2 pi. We start at the origin. We just have to get up to 3 and down to negative 3. This 3 is called my amplitude, and we'll go through that on the next page, what these things are called. Amplitude is just saying how high and how low. We got to go up to positive 3 and down to negative 3. Okay, what about this sine of 2x? So here's what I want you to do now. Let's go back to our calci. I want you to keep your y1, but in y2, I want it to be the sine of 2x. I want us to see the original, and then what is the 2 with that x going to do? Ooh, it looks a little weirder. What's red doing? More frequent, right? It's a little more squished, if you will. You guys, what do you think the period of this red graph is if blue graph's period is 2 pi? Yeah, it's 1 pi. So you guys, when we go to graph this guy, is my amplitude still 1? Yeah, because it was 1 sine of 2x. The number in front was a 1. Excuse me. So I'm going to put in my guidelines of 1 and -1. And then what we've got to do is we got to say, all right, I know it starts at 0, but the period is now 1 pi in this case. So I'm going to go just to pi, and I'm going to put a 0. And then I know I got to cut that in half, and then cut that in half again. And sine starts by going up first, and then I'm going to continue that pattern. You're welcome for a perfect graph, labeled with axes. You know what I'm saying? It's a gift. And again, this is more frequent. Are you down with seeing that it was still a 1 sine of 2x? So we only went as high as 1 and -1. It didn't change my amplitude at all. But this little angle, messing with the angle, made it, as opposed to like this, it was like this. Just tighten it in a little bit. So check this out. I was trying to give us some pictures. It says amplitude of, if I were to write this in like, this is very textbooky, right? A sine of theta. The A is the amplitude. And I want you to know that amplitude, when they're like, hey, what's the amplitude? They're always going to say it's positive. Even if a graph, like, for example, the amplitude here, it's just always the number out front. So the amplitude for this one, what would we say that is? 3. And then the amplitude for this one is still 5. We say 5, even though it's negative. It starts at -5. And let me just, I'm going to sketch you a graph real fast. Like, and you can or you can't write this down, whatever you prefer. But like what this 3 means is, again, I'm going to have these guidelines. I would go up 3 and then I would go down 3. That's what that amplitude is. And with the sine graph, I still start at the origin. And this amplitude of 5 is I would go up 5 and I would go down 5. But what does the negative do you think? Just means that I still start at the origin, but now I just start by going down first, as before I start by going up if it's positive. Does that make sense? So again, the amplitude is the number out front, but you always just say it's positive. Oh, the amplitude's 5 here, because what the amplitude tells us is how high and how low to go. Labeo? Oh, snap. She said the second one's cosine. Oh, snap. Let me back this up. Oop, it wouldn't start at the origin. So since this is cosine, this is so interesting. You guys, up 5 and down, we'd still have up 5 and down 5. You down with that, Steffi? So careful, real fast. Okay, cosine always starts where? At 1. So cosine actually starts, like if this was just the cosine of x, it does start at its amplitude. So that's why this graph would have started at 1, because just cosine is just 1 cosine. Where do you think positive 5 cosine would start at? 5. Where do you think negative 5 cosine is going to start at? It's going to start down. Yeah, you feel me? Right. Okay. If it was positive 5 cosine, I would have started up at 5. The last thing is that period, which deals with the frequency. Would you agree this red graph has less frequency than this blue graph? This blue graph is more frequent. And the thing that messes with the frequency is the angle, the thing with the theta or the variable. So the period of any sine or cosine graph, period is always 2 pi over k. And honestly, if I were us, let's just go write it right here. Period equals 2 pi over k. Give that like a circle. And you're like, okay, cool. But what the heck is k? Well, look at these examples right here. K is the thing, the number, with the angle. K is the number with the angle. Let's go up here. What's k up here? 7. What's k up here? 2. What's k here? 6. So let's do this real fast. It says state the period. I know period is 2 pi over k. And in this case, it'd be 2 pi over 6. So maybe you just draw yourself a little note and be like, that guy right there is K. That's K. What would 2 pi over 6 simplify to be? Pi over 3. So what this is saying is every third of a pi, whoosh, every third of a pi, you got to have a whole period. That's really little. That's really little. Okay. Anyone know what my K would be in this case? It's 0.5 or 1/2, right? Because if it was 2, wouldn't it be 2 theta? You know what I'm saying? So couldn't I rewrite my function as cosine of 1/2 theta? Is that the same as that? Yeah. Or 0.5. I could have used a 0.5. So you guys, in order to find the period of this one, period is always 2 pi over K. My K in this case is 1/2.
So 2 pi times 2.
Yes, ma'am. So she's saying in Lebeo, you were exactly right as well. 2 pi over 1/2. Dividing by 1/2 is the same as multiplying by 2. Dividing by 1/2 is the same as multiplying by 2. So 2 pi times 2 gets me 4 pi. So this graph would be very elongated, right? It's going to take 4 pi until it repeats itself. Let's practice it. Let's put it together. State the amplitude and the period of this little guy, and then we're going to graph it. Wow, we're doing a lot, people. What do you want to say the amplitude is? Amplitude is 1/2. So I would just say amp is 1/2. And if I were us, I'd then go to my picture and I draw those little guidelines. If I'm only going up 1/2 and down 1/2, that's kind of annoying. Some of you might have been like, why would you go in the between? I'm just going to go here and label this as 1/2. You totally can. You can label your axes anything you want. What about the period? It's always 2 pi over K. What's my K in this case? 4. So now it's 2 pi over 4. What's that simplify to be? Pi over 2. Whoa, we've got to draw this cosine graph and get the whole cosine graph done by pi over 2. The period is pi over 2. Holy smokes. Okay, where does cosine start? Cosine always starts at 1 or the amplitude, right? Our amplitude here is, so I'm going to start at 1/2. So I'm going to go to 1/2 and I'm going to put a dot right on my amplitude. It's cosine, so I start at the amplitude. When do I get back to that point? What's the period? In this one, we just found out that the period is pi over 2. So I got to go to pi over 2 and I got to be done. So typically it was 2 pi. I got to scrunch that down. Then I'm going to cut that in half and I got to get to my lowest point. And I also like those guidelines. It helps you be like, all right, I got to hit the guideline every time. Then I got to cut that in between there. That looks like a straight up V. But we're going to be really cautious with our picture. And we're going to draw a really curvy, beautiful cosine graph. And we're going to go, woo, whoa. Oh, guys, it's pretty frequent. Get ready to turn curves pretty quick. All right, let's do it. We ready for the next one? Here we go. Now we're writing the equation of a cosine graph, so we're going to use cosine with this amplitude and that period. Weird. So when we write that, it's going to be like y equals blank for amplitude, cosine of blank theta. That's what we need to fill in to write the equation. You guys, if the amplitude's 9.8, what am I going to put right here? But what if Parker wanted to put negative 9.8? Could he? Yeah, you totally could. So if you guys put 9.8 and Parker was sitting here, he's like, well, I want it to start at negative 9.8. You totally could. The amplitude for this is still 9.8. We down with that? Then we got to go figure out what goes with the theta. Okay, let's remind ourselves, period is 2 pi over k. The k is what goes right here. We don't know what the k is. 6 pi does not go there. The period is 6 pi. So when I use this, could I substitute in 6 pi for the period to go solve for k? Sure. So I'm going to say 6 pi is 2 pi over k. Because I need to get my k. You could just put each of these over 1 if you wanted and cross multiply. If I cross multiply those, I'd get 2 pi equals 6 pi k. Divide by 6 pi, Steph. My pi's cancel out. That's 2/6. 1/3 equals k. And k goes right here. My k goes right there. 1/3. So I would take either this answer or that answer. So you'll often see on my answer keys, I would put plus or minus in front of my 9.8. Not that you guys need to, just letting you know either one works. Okay. So we've gone from an equation, graphing it, writing an equation. Now can we write the equation from a graph? Yikes. Okay. What would you say the amplitude is for this guy? You agree with a half? So the amplitude's half. It starts at the origin. So is it going to be sine or negative sine? I'm sorry, sine or cosine? It's going to be sine because it starts at the origin. Do I know it's positive half or negative half if I'm going up first? Positive. Okay. Guys, we got to go find out what my k is. We got to go find out what k theta is. That k deals with the period. I know period is 2 pi over k. Based on this picture, what's the period of this graph? How long until it repeats itself? Pi over 2. I think it's actually pi over 2, right, Labeo? So I'm going to say pi over 2 equals 2 pi over k. Then I'm going to cross multiply. And I'm going to say pi k equals 4 pi. Get k by itself, I would divide by 4. I'm sorry, divide by pi. And I get k equals 4. And that's what goes right here. Whoa. Okay.